Okay, good morning, good afternoon to all of you. Took a little while to get my technology up and running, but now that I've got it good, we can do this, okay? So we're going to use substitution to solve for x and y, this important skill. It's part of our RFCs as well as we're going to need it for today's lesson. So what this is saying right here is that we already know what y is equal to, so we're going to substitute this whole value in for y right here. So I have 4x plus 1 over 3 times the entire quantity, 3x plus 9, and that is equal to 18. So now we're going to just follow order of operations and solve our equation. We're going to distribute here, and we get 4x plus x plus 3, because 1/3 of 3 is 1 and 1/3 of 9 is 3. Now I'm going to combine like terms and go ahead and subtract. I'm going to do it over here. Subtracted 3, get 5x equals to 15, and when we divide by 5, we get x equals 3. You repeat the same process here, but this time we're saying x is equal to something, so this entire value gets substituted in for x. So we have 5 times y plus 1 minus 3y equals 17. Go ahead and distribute 5y plus 5 minus 3y equals 17. Combine like terms, 2y plus 5 equals 17. Subtract 5, and last divide by 2. And now we found the values for both, and my answer is x equals 3 and y equals 6 for these two different problems, but I need to have both x and y. So once you solve for x, you plug that value back in. Here I'm going to plug it in here. So 3 times 3 is 9. 9 plus 9 is 18, so y is equal to 18. Over here, I'm going to plug the value in for y, and it's y is equal y plus 1, so x is equal to 7. These are my two final answers. All right, obviously we can't answer any homework questions. RFC question number 15, we'll have to review it later. We'll go ahead and review it Monday before I collect that work. All right, properties of parallelograms. We started this yesterday. And we're going to go ahead and continue on today with the second part of it. So theorems 6-3, 6-4, and 6-5. 6-3 right here, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So this side is opposite from this, and they're the same, and this side is opposite from this, and they're the same. The next one is if a quadrilateral is a parallelogram, this is 6-4, then its consecutive angles are supplementary. Consecutive angles are angles that are next to each other. So this angle right here is consecutive with this angle, and they're supplementary, meaning they add to 180. Next is if a quadrilateral is a parallelogram, then its opposite angles are congruent. So now we were talking about angles that are opposite, are across from each other, and these two angles then are congruent. So now we're going to move on to our next theorem, the parallelogram theorem, which is also known as 6-6 for our book. If a quadrilateral is a parallelogram, then its diagonals bisect each other. The first thing that we need to understand is what is a diagonal. A diagonal is just what it sounds like. It's from going from one corner diagonally across to another corner, and same thing here. So I have two diagonals here. One is the diagonal BD, and the other diagonal is AC. Okay, so this is just what it shows up as in your book. If ABCD is a parallelogram, that's what it's saying here. This indicates the parallel. And then this go ahead and tells you that they are equal, right? So bisect means to cut into two equal parts. So when we look at this, and let's look at AC first, and let's go ahead and label a point here, E, in the middle. Okay? So from A to E is the same distance as from E to C. That's what this is saying. And the same is true for the other diagonal. DE is the same as BE. Okay, so we can apply this here. So important thing is being able to decipher this equation. This is this section right here, y plus 10. This is here, okay? And so we knew from our theorems that KP is equal to PM. So then we can say y plus 10 is equal to 2x minus 8. But because there's two variables here, we can't solve for either variable. So we have to use the other diagonal to help us. Right here it says x, and we have y plus 2. So LP is equal to PN, and so we know x is equal to y plus 2. Now we're at a point just like our bell ringer, and that we can substitute this value in for x. So I'm going to do that and go ahead and solve. I have y plus 10 is equal to 2 times, and I now know x is equal to y plus 2, so I can substitute in there, and now I have one variable equation that I can solve. First step is to go ahead and distribute the 2. The next step is to combine like terms. Right here, these two are the same. They're both constants, so we can go ahead and just go ahead and, like this is the problem, 4 minus 8, which gives us negative 4. Now we have to combine like terms across the equation. I'm going to use this y here so I can keep my positives. We always start with a variable term first. So I'm going to subtract y from both sides. Remember, there's a 1 here. This leaves us with 10 is equal to y minus 4, and now I can add 4 to both sides, and I've solved what y is equal to. Okay, I can also find what x is equal to, because now that I have what y is, I can plug that value into this equation, and x is equal to 14 plus 2, and I get x is equal to 16. Okay, so I can find x and y. I can also find the lengths of these segments. So if they ask what is KP, I can then plug y into here, and I get 14 plus 10, and KP is equal to 24, which means PM is also equal to 24. Same thing with these two lines here. I found what x is equal to, so x is equal to 16, so y plus 2 is equal to 16, and that verifies 14 plus 2 equals 16. Okay, so now we have theorem 6-7, no name, just the number. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, this is a little confusing. What this is saying is, so here I have two lines that I've indicated are parallel. But that's not enough information. It says 3 or more. So I need to have at least 3 lines that are indicated as all being parallel. And then it says cut off congruent segments on one transversal. So I'm going to go ahead and draw a transversal. And what they mean by cuts off congruent segments is these segments right here. They're saying they're equal to each other. I know my diagram's a little bit off, but that's what we're looking at. Okay, so then they cut off congruent segments on every transversal. So what that means is I could draw another transversal. It doesn't even have to be parallel to this first one, and these two segments are now congruent. I could even draw a third transversal if I needed to, and then these segments are congruent. Okay, and that's what the theorem is saying. The way it looks in your book is like this. Okay, so if AB, this line right here, AB is parallel to CD, which is parallel to EF, and AC is congruent to CE, then BD is congruent to DF. Okay, they are not congruent across each other. They only congruent on the same transversal. So let's look at an application. So they're telling us that AE is parallel to BF, which is parallel to CG, which is parallel to DH. That's the given right here. And it says AB is equal to CD, because this line right here is my transversal. And I'm being told that AB is congruent to BC, which is congruent to CD, and they all equal 2. Then it tells me EF, this little segment right here, is equal to 2.25. And the first question is, what is EH? Okay, EH, first we have to figure out what that is. EH is this entire line right here. But because of the theorem 6.7 or 6-7, this is that every one of these segments is equal to each other. So they're all equal to 2.25. And since they're all equal to 2.25, we can then add them up to get this entire point. So 2.25, you can add them 3 times or you can multiply by 3 because there's 3 segments that are 2.25. There's 2 points behind the decimal place, so EH is equal to 6.75. Okay, so now we're going to have a separate problem. This is a different problem altogether. So I'm going to go ahead and erase some of my annotations here so we can have our diagram. But we already know that these are congruent to each other. We already know that they're all equal to 2. But this next question is saying that EF is equal to FG is equal to GH, and they're equal to 6. And I apologize. Actually, we don't know what these are. Okay, so this is a different problem. They're giving us that these are all congruent to each other and they're all equal to 6. And now it gives us this entire AD is equal to 15. And they want to know, what is this little piece right here, CD? Well, since they're all equal to each other, we have 3 equal parts, AB plus BC plus CD is equal to 15. And since they're all equal to the same value, let's say x, by combining like terms, we can find out that we have 3x equals 15, and we can solve for this value of x or this piece and find that it's equal to 5. So CD is equal to 5. Okay, so how we have a parallelogram, and this is just using applications from before. Okay, so we have a parallelogram. Okay, we're going to put some given values into this diagram. So the first thing is this is labeled as angle 1. This is labeled as angle 2. Oh, angle 1. This is angle 2. And we're given that this is 48 degrees. And we're given that this is 85 degrees. So we're going to use all the information we know about parallel lines. Remember, this is a parallelogram. So this line is parallel to this. This line is parallel to this, and we're going to use this information to find all the angles. So the first thing I'm going to highlight here is these angles right here and this line transverse these two parallel lines. So we know from 2 or 3 chapters ago that two lines that are parallel with a transversal create alternate interior angles, and we know alternate interior angles are congruent to each other. So that's important to know when we get there of that information. Also, we can see right here these two angles form a linear pair. So we can go ahead and take 180 and subtract 85 to find what angle 1 is. And we get 95 degrees. So angle 1 is equal to 95 degrees. Now, right here, we have a triangle. And what do we know about all the angles in a triangle? They add to 180. So we can take this 95, add the 48, and then subtract that value from 180. Now we know that angle 2 is equal to 37 degrees. And then what did we say at the beginning here? Angle 2 and angle 3 are alternate interior angles, so they are congruent to each other. We don't have to do any more math. We've now solved our problem. All right, so here's your homework right here. Don't worry about this classwork because obviously we weren't in class today. It's in the book. I've posted photos of the book in case you didn't bring your book home. And that's it.